Next up, we have BAS Services and Graphics. Founded in 2004, BAS-G has been an innovator in building automation technology and BAS analytics delivery that reduces implementation and facility management energy costs. Here to help us experience the BAS-G difference is managing partner Alper Uzmesler. Take it away, Alper.
Hello, my name is Alper Uzmesler. I am the managing founder of BASSG, and we distribute Anka Labs products. The system architecture for the smart building space is changing due to a variety of factors. One of them is microprocessors prices are going down, and this enables us to change the architecture within the BMS systems. And in the last couple of years, we have done some pilots, and we would like to share those. One of them is airflow monitoring, rooftop unit control, variable air volume box control, and air quality monitoring. The new workflow of new era distributed computing is as such. You can do controls within the same device, as well as you can historize the data within those devices. And you can do analytics, and we are utilizing SkySpark that John Petsy will be talking within the next session. You can cluster all these devices together so they can talk to each other, and you can visualize the data from this cluster. And the data that is generated here is not only time series data that is created from systems, there's also data like from CMMS that is built into the system. You can ask questions to the cluster, any kind of data from the data that is created from the points, and as well as other CMMS data. We have also written an open source programming language called Project Sandstar. And within this, we can actually program these devices, real-time devices, through the oncolytic clustering system. We have also built in provisioning system. Just like your phones, these devices will need updates and patches, and we need to be able to deploy those faster. So in our systems, we have already created provisioning application. First, Project Sandstar. It is the first hardware agnostic controls engine that is built on new technologies. The existing building systems are proprietary, and they're built on old technology. The solution is hardware agnostic, open source controls engine, and we basically created Project Sandstar. So what is Project Sandstar? Existing building systems are created by the software from the same manufacturer, and the code that is generated is not portable between different devices. We basically merge Sedona with Haystack. By doing that, we can actually port these different systems together. We have basically merged Project Haystack with Sedona framework onto a seamless whole. We have chosen Project Haystack because we can utilize Haystack's system for value generation. Value generation is highly automated by doing so. So within the controllers and devices, we have analytics, visualization, and mobile application all bundled in a single device, and they are able to connect to each other. First, hardware. Within the hardware, we have generated a couple different types, and we have generated a MODBUS device, and we are working on a PoE device. Within the EAC, within the distributed computing, this is a project that we have done that has 4 compressors, they're 20 tons, and basically you have analytics running at the edge within the device itself. And this is clustered to a single instance, so you can look at the data from this rooftop unit. Within this project, we utilize Visualytic, which is on the right-hand side. You can see the airflow system, and it's running Project Sandstar, and we have Oncolytic and Mobilytic. Sandstar Web Editor is basically built into these controllers, and you don't need any licensing to program the devices. You just need browser. And you can program these devices through secured clustering that Oncolytic offers. We don't have to deal with any firewall or IT systems in order to build these interfaces. EAG MODBUS. So EAG MODBUS is a device that where we are utilizing MODBUS RTU and bringing data in. So one of the projects that we have done with Paxton Controls is that they have a valve, and we integrated their devices with MODBUS RTU so they can analyze access with mobile application. They can do analytics optimization to their set points, and they can create a maintenance management system built in through this distributed architecture. Indoor air quality sensor. So this is a device that we open source the hardware of, and we open source the Sandstar data collection part. And we have built-in analytics, oncolytic analytics within the device. We have installed this device in over 20 different locations, and we are utilizing PoE during the installation. Basically, as soon as you power it up, you're collecting the data for these devices. And what you're seeing is basically a particulate matter collected all the way around the world. Industrial analytics. So with utilizing the EAG MODBUS, we have done a industrial analytics for a factory. The numbers are skewed due to their intellectual property, but what you're seeing is a single recipe on a dashboard. And on the left side is individual recipes, recipe stages. So if you go to the next slide, this is an individual recipe, and you can see the stages as a bar chart. What the customer achieved by doing this is that they were able to compare individual stage runtimes, and they improved their operations and their recipes over time. We are working with Redaptive Power Meter company to include these analytics built into the device. This is basically an interface of our status. Basically, as soon as you plug in the meter, it collects the historical data. You can do analytics, real-time pattern analytics, and historical pattern analytics. It basically has the built-in SkySpark system, and you can cluster it to your cloud seamlessly without requiring any firewall rules. Also, this has BACnet IP server as well in order to integrate the existing BMS systems, or you can utilize Haystack. We are handing out 3 EAC pies. We are working with Contemporary Controls where we wrote Project Sandstar. So if you join onto that, you will have that. The last part of the application is that we have Mobilitic. This is basically Mobilitic. It can connect to every device, regardless of its system, being a controller, indoor air quality sensor, or a power meter, and you can create ticket management system all in this distributed approach. So what you're seeing is the interface of the Sparks that Mr. Petsy will be talking about for analytics rules. And this is basically an ARC app where we are able to take a photo and put notes on it, and you can see the same ticket management system. And all these tickets are literally stored in the devices. And when you access it, it is seamlessly seen in a single view. Thank you so much.